Hey, class, I'm back with part three. In part three, I've already shown you all the two methods, so it's not like I'm showing you another method. I am about to do some word problems for you all so y'all know how to approach the word problems and how to set them up, how to actually come up with your answer, and how to answer your word problems also. Okay, so here we are. Here in this section, letting you know another method to solve the systems of equation is by graphing. And I had mentioned that earlier, but we're not doing graphing in this section. Um, if you had to graph the two lines, the intersection where the two lines meet would be the solution of the systems of equation. Okay. So the intersection of the two graph would be your solution. And remember, your solution again, when we talking about just solving this, is an order pair, x, y, right? So that would be your solution right there, okay? But once again, your problem should not ask you to graph. It should either ask you to solve by substitution or the elimination method. And I already checked the homework and it did say substitution or elimination method. Now, another thing that I did not go over at the beginning because I just went into how to solve them, the two methods, is let's talk about the type of systems you can have. You can have a consistent system and an inconsistent system. Any system that produces an answer, at least one answer, is a consistent system. So any system of equations that we get that give us one answer, or it says infinite number solution, that gives us at least one answer. Infinite means you got many answers, but you got at least one there, right? That's called a consistent system. Okay. An inconsistent system of equation is when you get no solution. Okay. An inconsistent system is when you have no solution at all. And the only time we had that when I told you two lines are parallel, right? So that's when you had an inconsistent system. Okay. Now let's talk about the equations that are in the system. Are they dependent or independent? Right? The type of equations. You can have an independent and dependent equation. Dependent equations are equations that end up being the same thing. They're identical. These are equations that are identical. Okay? Independent equations are equations that will always be different. No matter when you simplify them or if you were to solve them for y, they would be totally different. Okay? So identical equations that when you simplify it, it end up being the same. The two equations end up being exactly the same. Independent equation is when the equations are different. The two equations are different. So once again, let's go over the system, review of the system. You can have two systems, a consistent or inconsistent. Any system that produces a solution, I don't care if it's one or if it's many solutions, it's called consistent system. If you do not get a solution at all for a system that's inconsistent. Now, type of equation, dependent and independent. Dependent equations will be the same thing. If you simplify them, they will look exactly the same way. Okay? And then independent equations are equations that are different. Okay? Now, let me draw something for you real quick just to keep this in mind. If I had for you, right, because I didn't draw this before, but you could write this in here. If I give you a set of parallel lines, right? Let's talk about this. Set of parallel lines. They're right with me. This would be an inconsistent system. And it would have independent equation. Right? Because don't we see two separate lines? That's how we know they're different. The equations are independent, right? So what if we had a system like this? Let me go here. Okay, so let me go back real quick. And I'm going to label these are parallel lines, and y'all know that. No solution, right? You don't see these lines intersecting at all, right? So here, look at this system right here, right? These are what we call intersecting lines, right? It has what? One solution. This thing right here in the middle is the solution, right? Now, let's talk about what type of equation and system it has. Don't you see that it has at least one solution? So this is a consistent system, right? Don't you see two equations? Because you see two lines point two different ways. So these equations are independent. Okay, just drawing it, showing you with a graph. How, I mean, not with a graph, but with a mapping, and you able to see. Now let's talk about the very last type you may see. You might see this right here. Okay, all you see is one line. You really have two equations now. You start off with two equations. This is called identical lines. Right? This is what it's called, identical. You started off with two equations, but what happened? The two equations end up being the same exact thing. So, yeah, every point on this line, so let me do the black dot. Y'all see that every point on this line, there's so many points on this line, is a solution. So it is an consistent system, because every point on the line is a solution. But the equations are dependent. Because guess what? You only see one line. You don't see two separate lines, which says they're independent. So you have dependent equation. Okay? So just giving you that reference. I know I gave it to you in words, but here I'm giving you a diagram of what it could look like if you have a picture in front of you. Okay. Now let's go on to solving these word problems. And these word problems, right, involve these systems of equations. Everybody with me, right? And we're not dealing with this. In my math lab, I come back to this real quick before I go to word problems. In my math lab, as y'all doing the word problems, it's going to ask a couple questions. Tell what type of system it is, what type of equations. So that's why I want to make sure I cover that with you all, so you all have that information. Okay. Now, let's go into the word problems real quick. Now, remind you, these word problems involving systems of equation. On my test, you have to show me your work, because I'm looking for several things. And on my test, these word problems are going to be worth more than the other problems. Just going to be telling you right now, because I know that I'm looking for every part of it. Okay. So now let's read this. The sum of two numbers is 47. The difference between the numbers is 1. Find the numbers. We don't know. And you all can guess all day long. We're not talking about guessing. I need you to show me algebra, not guessing, because I can't read inside of your head. Okay. So I don't know what these two numbers are. The first thing I do, this is part A, I define my variable. First number. I don't care what letter you use, as long as you use two letters. Okay, this is my second number. And I'm telling you, when I get to these word problems, I am looking for this step by step. Any step that's missing, you get minus off. So I'm breaking it down to you so you understand how to do this correctly. Okay, next thing. Now I want to create the equations that's given to me by this. I'm going to turn these turn these sentences into equation. The first one, the sum of the two. Well, you all know sum means plus, right? So if I add these two numbers, it should give me 47. Here's my first equation. X plus Y equals 47. Got my sum. Second equation is the difference between the two, is the numbers is 1. Well, you all should know difference mean that when I subtract, right? When I subtract the two, I'll get 1. So I get X minus Y equals 1, right? That's what I have. I have defined my variable in part A. I have set up my system of equation in part B. Part C is now I need to solve. I don't care what method, because I don't tell you a certain method. Which method you find easy. Both method works here. Substitution and elimination. But if I was doing it, I would do elimination. That's just me. Both method work here. So part C, I'm using elimination method right here. And you don't have to tell me what method you're using. When I see it, I'll see it, right? I'll see it, okay? I'm just showing you for when you try to do the problems, you'll know how I did it. Elimination method. Why? Because when I look at this right here, when I look at my y's already have opposite sign. That's why I pick elimination method. So I'm going to write my equation down again. And I'm going to do elimination method. Remember, elimination method says I add. Now, I'm going to say this, so let me say this. You all have to give me part B. I do not want you working on part B. You have to write this separately because some of you all, I'm not trying to be funny, do not write well. And I can't understand what you're doing. So I have to see your system. I have to see your system. You will just have to copy it over again when you're trying to solve it. But I have to keep part B there because I have to see your system. Okay. Now, next thing, I'm doing addition method, right? I mean, elimination method, the same thing as addition. So I'm adding my x's, I get 2x. You all see that this will cancel, right? This cancels. And then I'm adding the other side, which gives me 48. Well, to solve for x, all I do is divide by 2. I get x equals 24, right? Got x. Now let me solve for y. Doesn't matter which equation, whether I use equation 1 or if I use equation 2. I just use one of them to solve for y. Okay, so I'll use equation 1. 24 plus y equals 47. I would subtract each side by 24 and I get 23. So y is my 23, right? My two numbers, you will tell me 24 and 23. These are my two numbers right here. That's how you give it to me. You don't have to put it in order pair because you're doing word problems now. So you don't write it as an order pair. You answer it accordingly, okay? So, and it may have boxes for you to fill in what you call them in my math lab. So you might say the large number, it would be 24, small number be 23. I don't know how it's going to ask, but for me, you could just do it like this, 24, 23. Those are my numbers. And if you want to check yourself, do it. 24 plus 23 gives me 47. Yeah, when I take 24 minus 23 gives me 1. Okay, so just check yourself there. Okay. Now, you don't have to tell me. This is part D for me. You do not have to tell me which method you're using. I can see it when you do it. But you have to give me all 4 parts. And I have to see this. If you work on this and start doing work on this, I'm not accepting it because I don't understand. You're going to have to rewrite this and bring this over here and do the work. I have to be able to see your system to give you credit for it. Okay? Hope everybody understands it. If you don't understand, you can email me, text me on reminder, ask me if you're doing something correctly. Okay? Second one, look what we're dealing with. Cost of goats and sheep. At the Burger Ranch, 6 goats and 5 sheep sells for $305. While 2 goats and 9 sheep sells for $285. Find the cost of a single goat and a single sheep. See, if you look at the very last part, it'll tell you, you get to figure out, like this right here where it says find the numbers. Look, this right here tells me my variables. It's not much for you to do. I don't care what variable, you can figure out what your variable is going to represent. I don't care what letters you use, as long as I understand that they're letters, okay? I don't care if you make them capital. That's up to you. But you have to have 2 different variables here. We're talking about the cost of a goat and the cost of a sheep. That's what we're dealing with here. I don't care which one you make what. Here, let's go. X is going to be the cost, and I use money sign of sheep. Of the goat first, sorry. That's what I'm going to do. This is part A for me, right? Defining my variable. The cost of a goat. And I use a dollar sign to let me know I'm talking about money. I'm not looking for the number of goats. I want the cost of a goat. That's why I use dollar sign. Now, next thing, y equal the cost of a sheep. So I could do that just like that. And this defined in my variable. I know I'm dealing with money with the goat and the sheep. I'm not talking about the number of goats because that's not what it asked me. Okay? So you could say cost of goat. You could do price of goat. However you want to. I just use a dollar sign to represent that, to shorthand it. Okay? Now, I got to come up with the system of equation. Part B is my system of equation right here. Okay? And look what it says. My first system is right here. I have 6 goats, 5 sheep that they sell for $305. Think about when you buy something at the store. Don't you have to take, if you buy more than one item, you take how much you have times the cost, right? We got to do that. We don't know the cost of the goat yet, but there's 6 goat that cost such and such, which is X. So I start off with 6X. And then we got to add the 5 sheep that we want to buy. So 5 times the price of the sheep would give me 5Y. equal 305. That's my first equation. Now, my second equation is right here when I'm talking about the 2 goats and the 9 sheep. So we got another scenario where somebody bought 2 goats and 9 sheep. Okay, so we got to write it as 2 goats, which is 2 times x, plus 9 sheep, which is 9y, equals 285. We have our systems of equation. I have to see this. Now, you are looking at the system of the equation. Y'all figure out how you want to do it. I'm going to use elimination method. That's just what Crystal choose to do. Ms. Ford choose to do. You can do substitution. That's up to you how you want to do it. Okay? I am going to use elimination method to solve this. And I choose to eliminate x. That's what I choose to eliminate x. Okay? So part C right here is I'm doing elimination method. And I am choosing to let go of x, right? I'm going to cancel out x. That's what so I want the same number but opposite signs in front of the x's, right? That's what I want to do here. Now, I'm eliminating x. So I can make 6, right? Look, we got 6 and we got 2. It's easy to make this 2 a 6, a negative 6, because I could take this row right here and multiply it by negative 3, right? I could do that. Let me put it in this so y'all can see. So say I'm multiplying this by negative 3 to make it a 6, because my concern is just x. I'm eliminating x. I'm not trying to eliminate y. If somebody wanted to eliminate y, you figure out what number you would do it. And if you're trying to eliminate y, you would make both of these 45, right? But one would be negative, one would be positive. It's up to you which one you let be negative and positive. I would do it that way, okay? But you got to multiply the whole thing by whatever. Now, I'm eliminating x. The only equation that I have to multiply is the second one. So let me keep the first equation, 6x. So I get 6x plus 5y equals 305, right? That's the first equation. That keeps it like that. Second equation, I got to multiply by negative 3, right? Let's do it. Negative 6x, negative 27y equals, now let's multiply negative 3 and 285, right? 3 times 285, I got my calculator, I get negative 855. Did everybody get that? When you multiply it in the calculator? So 285 times 3, negative 3, excuse me, is 255. That's what I get. Now remember here, I need to multiply. I need to add, not multiply, sorry. So I'm adding that. Is everybody with me? Now look what canceled. Just like I said that I want to cancel is x, right? This cancels. That's what I want. So when I do y, I get negative 22y equals, and now let's do it in our calculators. Let's subtract. Let's add these two. We got 305 plus a negative 855, right? And I get a negative 550. Everybody with me? So then the very last thing is to divide by negative 22, right? I get y equals 25, right? Y is 25. Remember what y is. We define y as the cost for the sheep. Now, I'm not going to put dollar signs on just yet, because when I answer it, I'm going to put dollar signs on them, okay? Now, I got y. I need to find x. Does not matter if I use equation 1 or equation 2 to find x. It does not. Long as I find them. I'm going to use the first equation. That's just me. Well, let me use the second one because I'm always using the first one. So the second one, 2x plus 9 times 25 equals 285. That's what we get here. All right. So I have 2x. Sorry. 2x plus 225 equals 285 right here. Right. And then when I subtract, first thing I subtract 225, I get 2x equals 60, right? Next thing is divide by 2, x equals 30. So we have both x and y. Is everybody with me? We have both x and y. Now I got to answer my question. I want to know the cost of the sheep and the goat. Okay, know which one is which. X represents the cost of the goat. Y represents the cost of the sheep. So part D, when I answer this, I would say $30 per sheep. I mean per goat, excuse me, and $25 per sheep. That's how I would answer it. In my math lab, they probably have boxes for you to fill in. This is money. You have to represent it with dollar signs. You have to. If the dollar sign is already there for you, then you're good. But if you got to make sure you put in the dollar sign if it's not there for you. So it costs $30 per goat to sell and $25 per sheep. We just answered it. Last one, dealing with word problems. The fan cost index. The fan cost index, FCI, is a measure of how much it will cost a family of four to attend professional sports event. In 2018, the FCI prices for Major League Baseball and the National Football League averaged $383.34. Okay. The FCI for baseball was $305.40 less than football. What would the FCIs for these sports? So I want to know what was the FCI for both sports, basically. What was the FCI for baseball? What's the FCI for football? That's what I want to know. Okay, so that's what it wants to know here. So you could label it. I'm always using X and Y. I don't care what variable you use. X is FCI baseball, right? Y would be FCI football. That's what we want to know. And that's the fan cost index. That's all it is. Okay, so once again, I label it like that. Or you could say cost, use dollar sign baseball, dollar sign football, dollar sign MLB, dollar sign NFL. However you want to do it. I got to know what you're talking about. Okay, you can't just throw stuff in there. Okay, now look at your first equation. Your first equation is right here, where it says the price for the NLB and the NFL average. This right here. Is that right? Y'all know what average mean, right? I take whatever I have divided by the amount I have and set it equal to that. So this very first says what? The MLB, which is, I'm just doing the initials, and NFL. The word and right here is plus. That's what it means, the price of both of them. So I would take, this is A, part A, I define my variable. Part B is now I'm giving my equations, right? So it says the price of the two averaged, okay? So we got to do X plus Y. Average mean I divided by just two because there's just two of them, and it will equal $383 and what, 34 cents, okay? Right? Now, here's my second equation right here. The FCI for baseball was. The word was, is, are, all of that means equal sign. Right? So, guess what you can start off with? Baseball equal. Right there. Was $305.40 less than football. So, how do you represent less than football? Wouldn't you say Y minus the 305? Okay. Right there. That's our setup. This is our systems of equation. Right here. It is. Now, if I were you, you don't have to change anything. I'll leave it just like that. Because why? The very last equation, this equation right here, is solve for X. You could use substitution method to solve. So part C, I'm solving it. I'm using substitution method. I'm taking what I know for X, which is this right here, plugging in it right here. That's what I'm about to do. So let me do it. Y minus 305.40 plus Y on top over 2 equals this 383.34. Right there. All I did was plug X in. Now look at the very top. You're combining these two on top, this and this. That gives me 2Y on top. So I get 2Y minus 30540. All of this over 2 equals 383.34. Now, how are you going to get the y? When you get rid of 2 at the bottom, how do you get rid of 2 at the bottom? You're going to multiply each side by 2. So then you're left with 2y minus 30540 equals, was it 7? Let me figure it out. 788, I think it's something. Or I could be wrong here. Sorry. Let me figure it out because I put it in my calculator. 383.34 times 2. Yeah, I got it on 766. That was 788, but 766, 68, right? Now, how are you going to solve this? When the next thing you do is add the 30540. Okay, so we would add 30540. That gives me 1,072.08, right? The very last thing I do to get Y. Now, what represents Y? That's the FCI of football, right? So I got to divide this by 2. I get $536.04. That's what I get here, right? Now, I could take the first equation or the second equation, solve for X. Might be easy for you all to take the second equation. So let's do it. X equals 536.04 minus 305.40. And I get that X equals $230.64, right? That's what I get. That's what I get. And I'm definitely going to add money in my answer. Even if I didn't add the money symbol right now, I'm going to add it in my answer. Okay? So let's get it. Let's write our answer right now. D. Okay? So it wants to know what were the FCIs for both sports. The FCI for baseball was $230.64. The FCI for football is $536.04. So we found it, okay? In my answer, I got to have my money symbol. Now, what I've done is I've done 3 problems for you all, 3 word problems for you all, showing you step by step what I'm expecting. Anything different that doesn't look logical will not get credit. And these problems are going to be worth 10 points that I give to you, these word problems. So you want to make sure you have every step by step. That's my rule. You have to show all the work. Every last one of my tests have said to you all, show all work to receive credit. I'm not trying to figure anything out. I'm not trying to say, oh, is this a 2 or an 8? I'm not going to do that. I have already explained to you step by step how to do this. Now, I don't give you numbered 1, 2, 3, 4 steps, or you use A, B, C, D like I did. Long as I understand everything you have written on your paper. Okay? So, I've done 3 problems for you. You should be able to do the word problems for my math lab and understand them.